Hi, boys and girls. This is our review for the unit Shaping Earth's Surface. It's our second unit in our No Atom Science program, and we did a lot of different investigations and activities to build our knowledge. So let's begin. In this unit, we observed and studied the natural processes that shape Earth's surface. So we talked about weathering and erosion and deposition. We talked about the tectonic plates. So we modeled the different ways the tectonic plates move to observe how the landforms are created. We used paper and we put sand on top, and we moved the paper apart to show divergent plate boundaries. We then pushed the paper together to show convergent plate boundaries and to talk about what landforms and events are caused by that. And we slid the papers next to each other to do a transform plate boundary and talked about what events and landforms are caused by those. We also tested how the force of moving water eroded sediment. We had our plastic trays and we put sand in them. Then we poured water at a flat slope, at a slight slope, and at a steep slope to see how the height of the slope and the force of the water can affect erosion or the movement of sediment. We then looked at clues in rocks, sedimentary, igneous, and metamorphic rocks, to figure out how the surface of the Earth has changed. We talked about Pangaea, the supercontinent, and how there were plants and animals that lived on all of Pangaea. And then when the plates moved and Pangaea was broken up into 7 continents, some of those plants and animals are found on different continents because it used to be one continent. We also looked at the Grand Canyon and the layers of the Grand Canyon, because we know that geologists use that to learn about the past. So we learned that Earth was formed about 4.5 billion years ago, and it's been going constant change and transformation since the beginning. We looked at the history of the Grand Canyon that is in Arizona as an example of how Earth's surface has changed over time, because it is one of the deepest and widest canyons in the world, and many believe it was created by Colorado River's erosion of sediment. So the water, the force of the Colorado River, which is, we know that all water flows down because of gravity, and the steeper the river, the greater the force or mechanical energy it is exerting on the rock, and it breaks it into sediment, and that's the weathering part. And then we know that erosion carries that sediment to another place, and it is deposited or cemented. So the layers of the Grand Canyon hold clues about Earth's history. We saw pictures of a quarry rock, of a quarry, and the Grand Canyon, and we saw that the different layers have different colors, and these give scientists one of the most complete geologic records on Earth. So they can look at each of those layers and figure out what was happening. So here are some pictures of the Grand Canyon with the Colorado River, and you can see how the force of the Colorado River weathered the rock and eroded it. And we can see the different layers, and we can tell, because of the different colors, there are different kinds of rocks that were formed in that time in our geologic history, millions and millions of years ago. We can tell what plants and animals lived there as well. This is a picture that shows the layers of the Grand Canyon and when they were formed. So this shows the history, 105 million years ago, 340 million years ago, 300 million years ago, 270, and now look at how high that is, 270 million years ago. And in the Grand Canyon, they have found trilobites and they have found shell fossils, and that tells us and scientists that at some point the Grand Canyon was covered by water. So like detectives, geologists who study the land and rocks, they piece together the clues about how Earth has changed by studying rocks, because rocks keep a record or a history of past life, and of what was happening, the processes that shaped us. So their rocks are made up of mixed mineral matter, and they make up the surface of our Earth and other terrestrial or rock objects like the moon and other planets like Mercury, Venus, and Mars that are also terrestrial or rock objects. So today, if you go to the Grand Canyon, it's a desert. But some of the layers of the Grand Canyon are limestone, which forms from the remains of marine organisms because they have calcium, and that creates limestone. So this tells scientists that an inland, and we talked about that in social studies, so an inland means it's not on the coast of an ocean. It's inside the United States, and it's just a sea covered the land in the past, and not just once. So the different layers of the Grand Canyon tells us that the land was covered with a sea hundreds of millions of years ago, and it has been underwater at least 8 times from the 8 different layers that they can see that are formed with limestone. So over time that has happened. There's also evidence that there were mountains that were taller than the Himalayan mountains, but they were weathered through wind, water, gravity, and eroded away or taken away to become flat. So we talked about the tectonic plates, and we talked about how Earth at the beginning was Pangea. So all of the continents were like puzzle pieces pushed together. And over time, the plates shifted and moved, creating our different continents. We then, when we learned about convergent, divergent, and transform plates, and we learned about what landforms and events happen, we then looked at where those boundaries are. And they're at the boundaries of the plates, where the plates are moving. That is where volcanoes happen, earthquakes happen, and mountains are formed. So we can see here that when the plates shift at their boundaries, it can cause earthquakes. It also causes magma to come through the creases and cracks and spaces to form volcanoes. It can also cause a trench or a valley. So these are the different types of plates that we modeled with the sand and the paper. We have divergent, where they separate or go in 2 different directions. We have convergent, where they go together, and transform, where they slide. And this is a little diagram that shows convergent, where they're colliding, and the land is destroyed. It's pushed together, and it can cause earthquakes, volcanoes, or mountain formation. Divergent, where they're moving apart or spreading apart, it's formed. So more is formed. So earthquakes happen. You can form volcanoes and or a volcanic mountain. And transform is where they slide, and that can cause earthquakes. So this is a transform, and you can see when they slide past each other, and you can see how with this road, it's causing an earthquake because the whole land has shifted. This is divergent, where the plates separate, and you can see the magma coming up, and that can cause a volcano or a volcanic mountain. And this is divergent, where they're pressing together, and we saw that on the previous page. We talked about sedimentary rock because we talked about how sediments, little pieces, can get pressed together to form sedimentary rock. So the sediments end up in the water, and they settle. With time, more layers form on top and on top and on top. And then that's how we get our layers. So these are sediments, and we can see how sedimentary rock have layers. So there's weathering, which creates the sediment. The erosion, it moves the sediment so that it's all together. The deposition is it's pressed there. Then it's compacted by the gravity and pressure and heat. And then it's really pressed together by the sun and other materials. And then we have our sedimentary rock. Now, we saw a sedimentary rock that had layers, but there are all different kinds of sedimentary rock depending on how they are what minerals have made them. And minerals are pure. And we talked about it's like a cookie. You might have a plain sugar cookie, but then you add M&Ms and peanuts and Reese's Pieces and raisins and nuts. Those are all the pieces of sediment that get pressed together. And depending on how they're pressed together, you can have layers or not have layers. So we took clay, we broke it into little pieces, we moved it, and then we pressed it together, because we talked about weathering, erosion, and deposition. And we had 3 groups. One group took the clay and broke it into little pieces. That's weathering, the breaking down of rocks into little pieces. And then erosion moves it. It's the movement of the sediment from one location to another by water or ice or wind. And then we pressed it together, and that's the deposition, when particles carried by water, ice, or wind are deposited. Right? So we did that with our clay. You had 3 groups, and we learned about that weathering is breaking down, erosion is moving it, and then deposition drops it and leaves it there. And we talked about sedimentary rock, but then we learned about the 3 different types of rock: igneous and metamorphic. So sedimentary rocks, if we look at these, and igneous rocks. So sedimentary rocks are created by weathering and erosion and sedimentation. Igneous rocks are melted rock that has been cooled and hardened. And igneous rocks, depending on how quickly they have been cooled, are either shiny, they might have crystals, or they can be like pumice and have little holes in them. And we talked about metamorphic rock. We talked about different types of metamorphosis that you have learned about, from caterpillars to butterflies, the mealworms, frogs. It's taking one type of rock, either sedimentary, and it goes through heat and pressure, and it turns into a completely different type of rock. It's taking igneous rock, and through heat and pressure and chemicals, it turned into a completely different type of rock. Okay. Now, this is our vocabulary that I kind of reviewed through all the pictures and background information. We talked about the convergent, divergent, and transform boundaries of the plates. And that's plate tectonics or plate movement. And we talked about convergent is when they are pressed together. Divergent is when they are pulled apart. And transform is when they slide. We talked about weathering is the breaking down of rocks into little pieces, and that erosion is the movement of that sediment. And sediment are little pieces of rocks. So we talked about the tectonic plates when we talked about the boundaries, and we talked about the tectonic plates when we talked about Pangea, the supercontinent, and how the reason it was broken into the 7 continents was because of the plate tectonics, the movement of the plates at different boundaries, types of boundaries. We talked about fossils, the remains of plants and animals that can be in the different layers of rocks, like in the Grand Canyon, and that creates a fossil record, or telling us what is going to be happening. And I think I skipped that, actually. Here's the fossil record. I skipped that whole slide. Okay, the fossil record tells us what kind of organism lived in the past, a plant or an animal, how the environment has changed, if it was a forest, or how organisms have changed. And there was a group that looked at different fossils, and they realized that some of the fossils the plants or animals lived in water, and some of the plants and animals lived on land. And so when you look at the layers of the Grand Canyon, they're different periods of time, and this is billions of years ago, millions of years ago, and you can see that different types of animals and plants lived during different times in history. A lot of people know about Jurassic Park with the dinosaurs, but that's all the way up here. Geologists and scientists look at billions of years ago and fossils, and that's the wonderful thing about the Grand Canyon, because you can start way down here and see what plants and animals were living in these different time periods. And it tells you what the land was like. Was it dry? Was it a wet swamp? Was it a forest? Was it an ocean? Was it a fresh water sea or a saltwater sea? So these fossils hold clues because we have imprint fossils from plants and animals. We have fossils where if an animal died and their bone was there, the minerals take the place of the bone. So when geologists or archaeologists find dinosaur quote unquote bones, they're not the actual bones, but they can do different tests on the mineral bone to determine how long ago it was and other factors. Here's another fossil record that shows you, oh look, the horn fossil, we had that in our unit. The first fish, here that looks like a squid. Land plants, and then amphibians, reptiles, we have mammals, the first birds, and then humans. So there's a lot of time that goes along, and the fossil record gives us all this information. Okay, so now I'm going to give you a sneak peek of the test. So we have our vocabulary questions. What is a process that contributes to the rock cycle? Is it weathering, eruption, evaporation, or fossilization? Think about that. The rock cycle. How are rocks formed? What forms rocks? Then, particles of sand, soil, minerals, and plant remains are examples of sediment, fossils, weathering, or erosion. And the key word here are remains. What remains after these things die? So think about that. A dinosaur bone is a type of, so this is a dinosaur bone. Is it an igneous rock? Is a dinosaur bone metamorphic rock? Is a dinosaur bone a fossil, or is a dinosaur bone an imprint? The supercontinent existed 300 to 200 million years ago. So is the supercontinent North America? Is the supercontinent Antarctica? Is the supercontinent Pangaea? Or is the supercontinent Australia? So the continent crust and oceanic crust are made up of, so what is our Earth's crust made out of? Is it made out of rocks? Is the Earth's crust made out of magma? Is the Earth's crust made out of water? Or is the Earth's crust made out of mantle? And finally, an igneous rock becomes a sedimentary rock through the, so how do rocks change? Through the sediment cycle? Do rocks change through the lava cycle? Do rocks change through the water cycle? Or do rocks change through the rock cycle? Okay, and then we have some thinking questions. Why might a mountain that used to be 1.5 kilometers tall become only 1.3 kilometers tall? So it got shorter. So something happened to the mountain to make it not so tall. Well, what would make a mountain get shorter? Would it be weathering? Would a mountain get shorter because of earthquake activity? Would a mountain get shorter because of volcanic eruption? Or would a mountain get shorter because of gravity? Here's another thinking question. A river carries sediment from its edges to the ocean. So it's carrying the sediment. Over time, the riverbanks, so the sides of the river, grow wider, and a pile of sediment forms where the river meets, the ocean. What is causing this change? What is making the sediment be carried to another place? Is sediment carried through weathering? Is sediment carried through erosion? Is sediment carried through earthquake activity, or is sediment carried through landslides? How might plants affect the erosion of sand dunes by the wind? So sand can be moved or eroded by wind, right? Does that make sense that wind could blow sand around? Well, how might plants change that? So I hope you've been thinking, because the process that contributes to the rock cycle is weathering, because it's weathering, erosion, sedimentation, heat, pressure, and chemicals. Particles of sand, soil, minerals, and plant remains, so what remains after they die, or little pieces, is sediment. So particles of sand, particles of soil, particles of minerals, particles of plants. So little particles are sediment. A dinosaur bone, well, if it's a dinosaur bone, it's a fossil. The supercontinent, well, we know the supercontinent is Pangea. And the continental and oceanic crust are made up of, so what we were standing on is made out of rocks. We couldn't stand on magma. We couldn't stand on water. An igneous rock becomes a sedimentary rock through this. So rocks change, and it's a constant cycle, a rock cycle. That's how rocks can change. And finally, our thinking questions. A mountain might get shorter through weathering, right? Because weathering is water, gravity, wind that breaks rocks into smaller pieces. So weathering makes a mountain shorter. A river carries sediment, so it's carrying the sediment, and that's the key thing here. And what carries or moves sediment? Erosion is the movement. So how might plants affect the erosion of sand dunes? So sand can be moved by the wind. Why would plants kind of stop that or make it harder for the wind to move it? Well, we know that plants reduce the erosion of sand dunes because if they have roots and they hold on to the sand, and if they're doing that, they're protecting the sand from the wind. We know that wind erodes Earth's materials like rocks and sand and other items because it contains mechanical energy. When something is moving, it's mechanical energy. We know that erosion is the transport or movement of sediment by wind, water, or gravity. And we know that different factors can influence the rate of erosion, meaning when we did our experiment with erosion, with the sand in the plastic trays, we found out that the height of the slope, either flat, slight, or steep, affected or changed how much of the sand was eroded or moved. Okay, so I know this was kind of quick. You can play this over and over and over. You can look at your student reader. You can look at your science notebook. And we're going to practice in class as well. So I hope you enjoyed this video and that it helped you review what we've already learned. So all of this are things we already learned. And I know you'll do well. Bye-bye.